Once again, welcome. In this class we are going to talk about rational agents. We want to get a deeper understanding of rational agents. So as we highlighted before, a rational agent is one that does the right thing. Conceptually speaking, every entry in the table or the agent function is filled out correctly. So we all know about the table which we talked before, whereby you specify you come up with entries trying to specify the function what is needs to be done. So if that done successfully, then the rational agent will be doing all those that will be satisfied. So obviously doing the right thing is better than doing the wrong thing. It's expected in agents, but what does it mean to do the right thing? How do we specify that the agent is doing the right thing? So it means we are going to need a performance measure, right? So when an agent is plunked down in an environment, it generates a sequence of actions according to the percepts it receives. It will be performing in a particular environment where it's deployed, and a sequence of actions. So the sequence of actions causes the environment to go through a sequence of states. Now, if the sequence is desirable, then the agent is performed well. So how do we measure that it has performed well? Obviously, there is not one fixed performance measure for all tasks and agents. Typically, the designer will advise one appropriate to these circumstances, because you notice we've got different agents that we need to come up with in different environments. So a certain environment will require certain kind of performance measure. So the general rule that was then driven up was that as a general rule, it's better to design performance measures according to what one actually wants in the environment, rather than according to how one thinks the agent should behave. So we might look at an example whereby, for example, we have got a simple robot of cleaning in the environment. So rather than measuring the performance according to what needs to be done, for example, another robot might think maybe cleaning the dirt and putting back it's best, because since it's cleaning and putting back. But the correct thing which we would want a robot to do is to make sure there's no any dirt remaining. So other performance measure can be designed is what's best for the environment is to see the environment clean, but the other robot looking for what it's doing itself, even cleaning and putting back the dirt. According to the robot, it will be correct, but according to the environment, at the end of the day, we want a clean floor. It's just an example. So I think the broader definition of rationality comes here. We keep on refining it more and moving more into it as we go through. So what is rational at any given time? It depends on certain number of things. There are 4 of them. The performance measure, this one that defines the criterion of success. Number 2, the agent's prior knowledge of the environment. Number 3, the actions that the agent can perform. Lastly, the agent's perceived sequence to date. So for each possible perceived sequence, a rational agent should select an action for that expected to maximize its performance measure, given the evidence provided by the perceived sequence and whatever built-in knowledge that agent have. So there are quite a number of things which a rational agent or rationality depends at any given point in time. So we should have that in mind. So after defining the rational agent, you find that rationality. There is rationality, then there is what we might term as omniscience. Omniscience might be difficult to achieve. And in definition, an omniscient agent knows the actual outcome of its actions and can act accordingly, right? So, but in reality, it's very difficult to come up with that. We can, for example, someone is trying to cross a particular road in a city. They check both sides, they see it's very clear, and then they decide to proceed crossing. But accidentally, maybe an object is falling, maybe from the sky or from a plane, without noticing it, and it crashes them. So can we say that it was irrational to cross the road under those circumstances? According to rationality, one would have checked both directions and decided to cross. But when we say an omniscient, it's like it's a superpower whereby one knows that even if it's clear, but if I cross, then something is going to fall from the sky. So that's why we can say it's very difficult to come up with an omniscient agent. So there are other things that are very important we need to look at, like information gathering. In this case now, we are doing actions in order to modify. The agent will be doing actions in order to modify its future percepts. So it's like improving how it will behave in the future. If an agent relies on the prior knowledge of its designer rather than on its own percepts, we say that the agent lacks autonomy. So we would want an agent that learns, for example, that will not only require with what the programmer or the designer have done, have implemented, but we want another one that is autonomous, just like as a human being. Once teaching them, we can be confident that they can go further to learn other new knowledge. So a rational agent should be autonomous now, so that it should learn what it can to compensate for partial or incorrect prior knowledge. For example, the designer might not be able to put all the percepts, all the knowledge, but we want the agent to be able to learn, so that it compensates for the incorrect information that it has. So that's so when moving with the agent approach, which we are working with in this course, we also need to understand about the environment. So there's what is called the task environment. What is it? Task environments are essentially the problems to which rational agents are the solutions. That is what we want to solve. Or places where the agent is needed. So in designing an agent, or every kind of agent, be it a software agent, be it a robot, the first step must always be to specify the task environment as fully as possible. So we've got ways of defining or describing the task environment. So a simple one can be the one where we specify the performance. That is, we can come up with a performance measure, what is expected by the agent, and the environment, the actuators that are needed to be there on the environment to satisfy the environment and the performance, and the kind of sensors that are needed to feed the actuators the system. The table below, this table, it's a simple way to explain or to describe the task environment. Here we can specify the agent type. For example, we can just look at another different example whereby maybe you want to come up with a robot which is a taxi driver. So the agent type here is specified as taxi driver, and the performance measure, we think of performance that we require on the kind of agent. So we want it to be safe, fast, legal, comfortable, and maximize profits within the trip. So this kind of environment, it will be driving a car, and the car will be on the roads, its environment, other traffic, pedestrians, customers. That's an example of environment. And the actuators to accomplish such a task will be the steering, accelerator, brake, signal, on display. Maybe more can be looked at, and the sensors that we might need to give information to this kind of agent are cameras, maybe for perceiving, sonar sensor looking at range like that, speedometer, GPS to know where it is, odometer, accelerometer, engine sensors, and the keyboard. So that table there, you need to be able to come up with this one for you to be able to explain and describe the task environment without omitting such. So let's meet in our next class and continue to explore the agent approach.